Now, if I tell you how to implement a 16-bit carry lookahead adder, it becomes a very simple block diagram from here on. Let's quickly do that. This is how it's going to look, guys. So what we'll have is, we are trying to do a 16-bit CLA. What we'll have is 4 blocks. I'll tell you what is there in each of these 4 blocks. So internally here we will have G4:1 and P4:1, which will be a combination of AND on OR gates. So G4:1 and P4:1, correct? This will be G8:5. Again the same thing, only the names are changing. P8:5 because it's 5th bit to 8th bit. The equations will remain the same for 4 bits, only the terminologies are changing. Here it will be G12:9, P12:9. They are blocks. Internally they will be implementing this and this in these blocks. And here we would have P16:13 and G16:13. Very straightforward. We are implementing 16-bit. So if generate G4:1 is high, here we'll have the combination of our AND and OR gates. Very, very simple. So this is my AND gate, this is my OR gate, AND gate, OR gate, AND gate, and an OR gate. So let's see quickly. This will be my C4, correct? This will be my C8, this will be my C12, and this will be my C16. And we know the connections are same as here. So if G4:1 is 1, my C4:1 is high. If P4:1 is 1, then this is going to be my C0 or Cin. That will come as the input, and this will go as a second input to the OR gate, correct? Is everyone clear about that? Let's do it for this as well. So if G8:5 is high, my C8 is 1. Or if propagate is high, then it will take its other input as C4, which is the input to this stage, and this will go to the OR gate. So this is C8. Similarly, we can do it for the other gates as well. Remember, this is nothing but my OR gate. Don't get confused. So I'll be taking the generate here. The propagate will go here, and this will come here. As we have seen, it's very straightforward now. Propagate will come here, this will come here, and this is nothing but this. So this gives me a 16-bit adder CLA where you can predict the output just by looking at your Cin and with the help of group generate and group propagate signal. So suppose if you want to find the sum of this 16-bit CLA, we know that sum is nothing but A XOR B XOR Cin, where A XOR B is nothing but P, which is XORed with Cin. So for each corresponding bit, you can have your corresponding P and its respective Cin, or there is another logic also which we can use, but currently sum is not in the critical path, or sum is not very important to us. We are more concerned with C out, and that's the reason this is enough for you to know a 16-bit CLA, how carry is made faster. With that, I hope you have followed this. Stay tuned for further clips, and thank you very much.